Hello and welcome to another mini lecture from CS200, Chapter 8, User-Defined Methods. In this short video, we're going to talk about 8.5 through 8.8. Unit testing is an important part of evaluating methods to make sure they work. Think of yourself as part of a large project. If you're part of a large project, you're going to be doing a lot of unit testing. And that's testing out certain methods to make sure that they work as they should so that the larger project works. That's usually one of the first steps. Then you have other steps like regression testing and stress testing, etc. You'll learn more about this in CS350. Unit testing is looking at a small part of the actual program, usually a method at a time. And this is part of incremental development. This is a way of looking at each method and making sure that it returns the values you would expect it to do. A lot of this is being able to know and understand boundary conditions, meaning values in which you expect things to change. The book defines something called a test bench or a testing harness. And what this is a separate program that's just designed to test the boundary conditions and the method returns from each of the methods you're trying to do based on different input values. A test vector is one specific test, so a testing harness or test harness or a test bench is comprised of many different test vectors. So here's an example they have of converting hours and minutes, like hours colon minutes, to a minute value. Now, what they have here is a method at the top in which they're passing in they have two parameters, so they're passing in two arguments. And what they're doing is they're calculating and returning a value. Okay? So it's not designed to work correctly, it's designed to test out this testing harness. So each of these lines here, system out print line, 0, 0, colon 0, expecting 0 got, and then the actual value, each of those is called a test vector. Notice the importance of putting a testing started and testing completed at the top and the bottom of this actual test. The reason is because you want to make sure that you know that testing started and it's not due to some other error that happened prior to the commencement of this harness. And the testing completed would tell you that actually it got completed. Now look at the choices they made for testing values in this test vector. You can see that they tried for boundary conditions. 0 hours colon 0 minutes. They're expecting something and then they get whatever returns from this method. 0, 1, 0, 99. Then they try 1 hour, 0 minutes, and so on. What I'd like to do is talk about the assert operator. Now the assert operator gives the ability to do a evaluation and then print out a message if, for example, that assertion fails. Okay, so again, here's our testing harness, but this time we're using assert. You can see that the structure looks very similar to what we did just now, but it has assert and then it has a conditional expression here. And if the expression here in parentheses evaluates defaults, the message after this colon will appear. So this is the message that gets printed out. Now it doesn't just get printed to the program, it actually gets printed out like an error message, so it's very obvious. We'll see an example of this in BlueJ. So again, this is what the message looks like. Let's go to BlueJ and see what it looks like for us. Okay, so this is the exact code that we got in from the textbook, and you can see here we're using the assert. And so we test to see if it compiles. Everything is fine. And then we close it. And now we want to see it run. So what we're going to do is we're going to run it. And lo and behold, it comes back. And notice down here, we have an assertion error. It says it failed. And let's take a look at the output screen. So you can see here the testing did start. and then we got a message. This looks like an error message that we would get in BlueJ. So this makes it very obvious to the tester that the actual assertion did not work as expected. So the nice thing about it is, even though the textbook says you have to compile or work with the -EA flag to enable assertions, in BlueJ it does it automatically. I didn't set anything specifically to get this to work with assertions. So going back to our textbook, it's important to know and understand border cases. Just like in any kind of mathematical approach, we want to know, for example, where are the weird conditions going to happen in the method? So it's a little bit of art and a little bit of science to know what they are. But here we have an example. Okay, so in this one they're doing cubes. I'm going to skip this one for now, but you can see it's important for you to understand how to do this effectively. So choosing the boundary conditions is important. Now, a more interesting chapter is how methods work. Okay, so what's interesting in Java is it's a pass by value. And what we mean by pass by value is when we have main, let's just say we have a bunch of primitive data types, such as integer, perhaps string, or character is actually the primitive data type. A string is an array of characters, or a double, or a float. What those do is when Java makes a call to a method and you're passing some arguments as parameters, what's happening is it makes a copy of the actual arguments that are being sent, so that you have two copies of that. One is the one that we started with in main, and the other one is what we start with in our method. There's two ways in which programming languages typically work with values when they pass to other functions or methods. One is pass by reference, and there you're just using a pointer or a memory address, and you're actually just passing that pointer. The danger in that is because you don't have two copies of the variables, if you mess up one in the method and something happens with the return, it can actually make lots of issues with the values you return back to that are working in main. The pass by reference is more efficient, but unfortunately it has the drawback I just mentioned. Pass by value is common in most programming languages today, such as C#, Java, Python. It just makes for a more modular approach to working with variables. Now, when we talk about classes, those are done pass by reference, but we'll get to that when we talk about classes. So just assume that we're talking about pass by value, and when we get to discussing arrays, which is not a primitive data type, we'll actually do pass by reference as well. So I would go through these exercises and make sure you understand how the information's being passed to as arguments to the methods and how it's being returned. And what happens? What happens is inside the method, the value that's returned, of course, is returned, but all the other temporary or local variables, those get just discarded or actually put on the heap, which is an area of memory that's reused quite frequently. So I would definitely go through this 8.6.2 example. It's actually pretty interesting to see how things go, and it does a good job of explaining what we see and what gets put onto the stack and what's happening each step of the actual process of calling the method. I'm not going to go over it in detail, but an explanation here is given below. I highly suggest you do it so you can understand what's going on behind the scenes. It will save you a lot of trouble later on when you're trying to debug your code, when you're actually passing arguments to methods and expecting it to behave a certain way. The next section, 8.7, talks about common errors. One of the biggest errors that they mention is cutting and pasting. Okay, so they started with the code here on the left, and they wanted to convert. The first one on the left converts from Celsius to Fahrenheit, and then on the reverse, it goes from Fahrenheit to Celsius. But what they want to do here is they want to return Celsius value, but they forgot, and they just made a cut and paste error. And you can see here they forgot to change it here in the return value. So of course this is going to cause problems. This is a good way why we want to create a testing harness to do it. But just realize that copy and paste is a very common error, especially when you're trying to make code based on other code you've either written or seen. Okay, so Celsius to Kelvin is an example they go through. It's just an important thing for you to realize is if you do copy code, you have to be very careful and make sure that you test it thoroughly. Okay, let's go on to chapter 8.8, which is how arrays are done. So remember, a primitive data type has no impact on arguments. So again, integers are primitive data types. We have doubles, we have floats, we have characters. But arrays, whether they be strings, which are arrays of characters, it actually works as a pass by reference. So it makes modifications to the exact same array that's being held in main. And that can be very misleading because we would expect that when we pass it as an argument, it's being received as a parameter inside this reverse vals method. We would expect that we would pass back this array and it would just overwrite what's in main. But actually we're actually working real time with the same method. So let me show you in PowerPoint. So remember this program, what it does is it swaps the values. The details are in the actual textbook. I'm going to just highlight the code that's missing, and the textbook is asking you as a challenge exercise to fill in that remaining code. So local to main, we have an array. The index is 0 through 3. There's 4 values. And it starts with 10, 20, 30, 40 as values being stored in that array. So here's the actual code that we want to look at. This code is not given to you in the text. It's code that you want to add. So we created a new method called swap array ends. Notice the void keyword. We're not returning anything, so we put void in there. And notice the parameter. The parameter is an array of integer called input array. And we declare inside the method an integer called temp value. This is just going to store a temporary value. So inside of swap array ends, this method that we've just built, we have temp value, which initially has a value of 0 because it hasn't been assigned any value yet. So remember, the purpose here is to swap the ends of the array. So what's showing up here in this element 0, index 0, will be a 40, and then on the other end in index 3, it will be a 10. So first of all, we take the value of element 0 of input array, and we set that to temp value, which we've done over there. Next, we move, remember with arrays, by saying input array at length -1, that gets us to the very end. Because the array is an array of 4, in length -1 gets us to the third element. And we copy that to the element 0. The next step is to take and set the last element, element 3, equal to what we've got in the temp. Okay, so it's just kind of a swapping mechanism that we're doing in this method. But notice that we're working on the same array that's local to main. We're not passing anything back. How do we know this? Well, we can see that we have void as the argument or the type of method, so there's no return values. So I encourage you to play around with some of these methods that they have in the text. I'm not going to go over them specifically here, but I am going to encourage you to use and explore on these on your own time. So when we modify an array parameter, and this is the exercise we just did, where we swap the ends. So just in summary, we've covered 8.5 through 8.8 briefly here. So just to summarize, we've talked about unit testing of methods, and we talked about the assert. We talked about how methods worked, and again, I highly encourage you to go through the explanation that they give in the Zybooks for that chapter. We talked about common errors, mainly cut and paste, and then also about how arrays work as parameters being called to methods.